welcome to the second episode of the XRPL4J programming video series. And today we will be sending an XRP transaction. So if we have a quick look here, last time we can see that we were able to import a seed. That we were able to derive from the seed the private and the public, so a key pair, then get the private and public key. From the public key we get the address, and that's it. So one thing is I am going to go into full screen mode again, so into the presentation mode in this case. Yep. And also I'm gonna be masking or like commenting out like this fund address command because it's not needed right now. And the next thing is, so for today we want to send XRP from, and then we will have our first address. So if I start the program again, then we can see the address. It was RN8 I think, or something like that. RA8, that's that one. We want to send XRP from this address right here onto another address we will now generate. So in this case, I am going to be hopping onto the XRP address generator. We can also generate our own. It more or less doesn't matter. Well, I guess we'll generate it ourselves in this case. Nah, never mind. Let's do it online. Because I think they add some like masking of the private key. So in this case, then we're just going to do it here for now. So if I just, again, enter whatever here, then we have here the family seed that I'm going to copy. So right now on the xrpdev.org website. And yeah, I've just generated one. I'm going to take the one here. And then we have our second seed for the receiver wallet. So from it, so I'm just gonna saved it somewhere. So we will have a comment there, wallet 2, and the family seed in this case is down here. We can also save the address. So we can also have a quick look at the address that we had before. That was ROK, that one here. We can also close it now. So this is in our case wallet 2. And then we have wallet 1, which we already generated in the first video. So this is here the family seeds, again same structure, and then the account address itself is the RA, not that one, the RA8, that one here. All right. So our goal is to send a transaction from this account to that account right there. Yeah, then let's get started. So the first thing we're gonna do is we're probably gonna so again, you can also copy that again one more time so we can see it here. Also the comment again. I'm gonna remove the fund account message, and now we're gonna handle the payments. In this case, the first thing we're gonna do is we have to get the fee structure. So we still have, we didn't even create our XRPL client, so that's also a thing we have to do now. So let's start with that. So we're going to be saying XRPL client equals new XRPL client, and then we have to specify the HTTP URL. So where it should be submitted to. HTTP URL.get, I think it was that one here. And now we need the testnet address, so we want to submit to. In this case, I will have to quickly look it up again because I forgot it. Right, so yeah, it's https //s.altnet.tripletest.net // and then 51234 and /. You can also see that on the XRPL website. So they have a section called public servers. So you can see to which servers you can submit public servers. I'm going to quickly show that. So if you have a look at, again, it's obviously behind it. So now one more time here. We can see here the public servers, and then you can always, these are the mainnet servers, and then there are the test networks, and you can use one of those RPC URLs, right? So in this case, I am using that one here. But obviously you can use any of those. Right, so now we've got the XRP client, and now we XRPL client, so we can now submit, so talk to the ledger, so the XRP ledger. And one thing we want to do, we have to first do actually, is we have to get the fee structure. Because as we know, whenever we want to send a transaction, there's a certain fee we have to pay. And now we have to query that what the current fee is, because depending on the workload, this fee gets higher or lower. And yeah, that's the first thing we're gonna do. So now let's get the fees. And in this case, we just have to say fee result equals XRPL client dot fee. And you can see the return type is fee result, and we also need to, well, it throws an exception. So I'm going to add this just to, to the main signature in this case, so to the method here. And yeah, then let's go on. And after that, we can already go further, because yes, yeah, exactly. Now we can already prepare the payment transaction. And we just create a payment, so call payment equals, and then we can use the builder pattern that is being used here, and then we could build at the end. And now in between we can set all the required properties, and first we're going to do is the account. Now we have to specify from where we want to send it from. So the account we want to send it from is in this case this one here, the address. And the account, so this thing takes an address, so we're going to just pass it address. We can also, so this is like your source, so it's like from where it should be sent from, right? Then the next part is now the fee. Now we have to specify the fee, and for that's why we create the fee here. And now we can just access the fee results. Fee results dot and let's see. Yeah, we can either get the base fee, but this is not that interesting. So let's check one more time. Yeah, with this also, well, in this case, fee, let's check one more time. Current ledger, so the fee levels, well, for now I'm just gonna say base fee, I guess, but I have to quickly check something again. Yes, so they have a fee utils class, so we can we can leverage that one, and then we can compute the network fees, right? And then it wants a fee result, and then we can pass it on. And this way we're fine, and then we can call the recommended fee method. All right, so this part here is, so obviously to define the fee, so we want to say how many drops are we willing to pay for this transaction to go through. Then the next part is we need the sequence, like meaning like what the current or at what ledger height we should, oh no, the sequence is from the account, I think. I will also have to check that. But first we need the account info. We first need to query one more thing. We're gonna use the XRPL client and do account info query. And then again we will have to well, so account info params off, and then we can specify an address. And then we got the account. So this thing returns an account info result, and I can again account info result equals that one here. And then from the sequence, we can then access the account info result dot, well, then the account data. Then we can access the sequence here. Then we also got that. And then now the next interesting part follows the destination. Where do we want to send it to? And in this case, we already mentioned it here at the top. So this RKMB wallet, we can also define it now. So I'm gonna just receiver wallet. I'm just gonna define the address in this case. We don't need to do all of these parts here. I'm just gonna say address receiver address equals, and then we just say address.off. And then we can define the string of the classic address, which would be that one here. Right, so now we also got the receiver wallet where it should be sent to. And then we're going to define the destination, the receiver address. So this is the account that should receive it. Then we have to define how much do we want to send. And there's the XRP currency amount object, and then we can say off, and then we can say off XRP or off drops. So we can define either if you want to define the drops. So as you know, 1 XRP equals 1 million drops, if I'm not mistaken. So yes, I think so. And then or we can use the off XRP, then we can define it just XRP. So in this case, I'm going to say off XRP. This one wants a big decimal, so I'm going to say new big decimal. And I can, for example, define I want to send whatever 2.5 XRP, 545. Right, and then then let's go to the next part. Then the last part is we need to sign the public key. of the account, we define that address, and we can obviously get those from the public key here. We just had it right there, so now we're just gonna say public key, and that's also done. And after having all of that, we are already done. So this is the payment object we need to that we prepared, and this is what we want to submit to the XRPL ledger. So in this case, on the testnet. And now we just have to do one more thing. We need a single signed transaction, signed transaction that is generic to payment. And we're going to just call it signed payment, payment equals, and then we either, now we have this one thing I have to check again. All right, so now we need one more thing. We need a BC signature service. BC signature service equals new BC signature service, and now we're going to use that one to sign the transaction. So this is the most important part. We're going to use the BC signature service dot sign, and now we want a private key. We already have the one here at the top here, the private key. And now we're going to use the private key to sign. And now the question is, what do we want to sign? In this case, it's this payment here. We've got the payment object here, and that's the one we want to sign with the private key. And then after having this signed, then there's just one last part we have to do. We have to submit it to the XRPL ledger. Then we're just going to say xrpl.submit. So this is then we push a transaction. And in this case, the signed payment. And this also throws an exception. So there's a checked exception. We're gonna just add it to the signature in this case. Obviously, you should have in your other programs, you should handle it somewhere else, but I just added here right now in the main method. And the submit method returns something, and what does it return? If you look at it, we can see here it returns a submit result with generic to payment. So because there's a specified payment here, so we get a submit result generic to payment. Submit result. And then in the submit result, we know what happened to the transaction. Did it go through? What is the status? Did it work? And so on. And now we're just going to print that. So it's just a system out. We can see here, there are just many messages. I'm going to just print the entire thing. And now we're already ready to test. So we are just going to have a quick look at BitHump in this case. Obviously, at the test at BitHump. So I'm just going to open it here. And again, I always do this mistake because IntelliJ always wants to stay on top in the window. So now we just have to specify two things. I'm intentionally holding it that way. Okay. So now we've got these two addresses. So obviously we've got that address here. And from this address, we last time already funded it, as you might remember. So we can see that we have currently a balance of 29 XRP. So there's enough. And the other account, which we today generated, so is the RK whatever account. You can see this account currently does not have anything yet. So this is not activated, right? So what we are now going to do is we're just going to start the program. And hopefully, if we didn't do any mistakes here, the account should be funded with 2.545 XRP. So yeah, let's give it a try and just say, in this case, run. So something did happen. We can also quickly make the logs a little bit bigger. And we can see here already, based on this result here, test success, meaning everything's great. So it did work. It has gone through. So we're getting there are a few like states, so ledger states, where so if we could quickly have a look at XRPL4J, not XRPL.org, there are like the tests. They're like, what is it? A result status or something like that called. Let's quickly see if we can get with test success. Yeah. Oh, maybe if we just go to payments, but this is a general concept. So whenever we submit any transaction to the XRPL ledger, we are giving back like a result. Yeah, the common fields, there it is. And in these common fields, we can see here there's one field called, what is it, result or something like that, I guess. Account, transaction, I don't know. Oh, this is what is submitted, but also we want obviously to see the results. All right, I found it. These things are called transaction results. So we can see here a result code, and then there are always prefixes. So tag meaning whatever was it, claim cost only. TEF is, so if there's an F, it's failure. TEL, local error. TEM, malformed, so something is not correct with the format. Try going to be applied, but it could apply successfully in future ledger. And then the most important one, the test, like meaning everything is fine, it worked, and we've got here a test and a success. And then we can see further specification probably. Yeah, if we click now on the test codes, for example, so this is on one, the test success, everything's great. Or there could be also like some error codes. So in this case, tag. So in this case, cost only. Okay, TEF codes. We can see here the failure messages already, bad off. Okay, no, this new one, bad underscore off. And so on. Like, there are many reasons why a transaction could have failed, but in this case it did not. And now we're just going to verify that quickly by having a look at BitHome again and looking at this not activated account yet. And now we can see, wow, we've got 1.545 sent to us, but to be more accurate, so available, I mean, but also we've got the whole 2.545, but one of that is the reserve. So yes, it did work. So if we just start the program again, so if we just click on the play button here, what we can see is that it's going to try it again. We can again have a quick look at the result. We can see again it's a test success, so meaning everything is worked. Now we're just gonna now we can just refresh, and we can see already the second transaction also came through here. So yeah, that's everything for today. I hope I explained this concept clearly. It's not that much code yet, so yeah, thank you for watching and see you in the next video.